Good morning, everyone. So the title of my talk today is Demystifying Ironic's Access Control Model. I'm Julia Krieger, former PTL of Ironic and longtime contributor, and also the troublemaker that has made most of these access control changes over the years, or at least more recently. The title of the talk is Demystifying Ironic's Access Control Model. Yippee. 'Twas the night before the deadline for every single RBAC change. And of course, then things changed too. This has been a journey. And when we started it, we had a great model. We knew exactly what we were going to do, and then there were changes. And that's normal. That's to be anticipated. And it just so happened that Ironic was in a really good place to adapt to some of these changes and enhance what we were doing. So I'll cover a couple different topics today. The first topic is the basic context, where it all started in the big picture. The next topic will then be owners and lessees. And you're probably going, what are you talking about? And we'll get there. Then we'll talk about system scope, then project scope. And then we'll go back to owners and lessees, and your eyes will be opened. At least I hope so. And then you'll have time for questions. So the basic context. Ironic started in 2013 as a service in OpenStack to deploy bare metal as a service. It can be used with and without OpenStack services. And infrastructure operators use it every day to deploy physical machines all around the world. And the story of Ironic and access controls largely started as it was an admin-only service. We used a policy rule called isAdmin, and it matched the role of admin, and that wasn't really great. Slightly problematic. And you can kind of see a bug that I've highlighted here, which is an infamous bug. People in Keystone can quote this bug. It's kind of frightening. I'm hearing chuckles from the audience, so I'm hopefully not bringing up too much scar tissue. But in 2016, as part of the policy and code effort, Ironic added a bare metal admin and a bare metal observer role. And the idea was allow operators to delineate who needs to read from the API and who needs to write to the API using these two roles. And this was in Ironic for quite some time and remains available today, although we're getting there. There's a lot to cover. And we are in a migration window right now. We are encouraging operators to move from legacy policies, which are the bare metal admin and bare metal observer, and just relying on isAdmin or role just admin, to the mindset of our newer secure RBAC role-based access control policies. The legacy policies are deprecated, and I believe they'll be removed, I think, actually, in the next release, or the release after. One after. So C, release, or D. Anyway, but that's all very confusing. Anyway, now to add to the confusion, owners and lessees. So the whole idea behind owners and lessees started as a server sharing model. In 2018, through early 2020, work started to add a resource sharing model through the MOC Alliance, formerly known as the Mass Open Cloud. And in their case, they had two different entities. They had a hardware owner that was distinctly different from the people running the data center, and then they had a hardware lessee, which might be someone else in another department needing to use servers. And so an owner in this case is just the physical asset owner or manager. It could be whoever paid for the original server, a department, or an entirely different organization. Or it could be someone who just has the primary role of administering and using the machine. A lessee is a user that has been given access to a machine. And in Ironic's role, or original model of use, it was manually configured. So you can say, and even today, you'd say, I want to give this machine to department Z. and I'm in Department A, and Department A is the owner, and Department Z is the lessee. That means that Department Z will be able to deploy the machine and use it, whereas Department A can go, I need to reclaim that machine now because I lost my other machines, and my workload's more important. To do this, originally, it required the use of custom policy. And the whole reason for this model was also so operators could claw back the machine. The use case that the actual mass open cloud operates in was one defined by a DR situation, disaster recovery. They have access to a large pool of resources that are available should there be a major disaster. But they have to be able to give them up rapidly. In that case, ironic makes a lot of sense because we have the logic for cleaning and scrubbing the machines. Unfortunately, this also means that if you're doing custom policies, it becomes a bit of a choose-your-own adventure. And we can always do better than that. And this did spawn some models of interaction that we didn't necessarily expect, where you might have a primary cloud with an ironic deployment, and then you may have another cloud with its own Nova deployment connecting into this same ironic deployment. And another cloud, and other users just using ironic. If we're all adhering to the same contracts, no one's the wiser. It just works. So to kind of give a visual delineation of how this looks, you have a primary pool in which all the machines exist, and then you may have a pool of lessee machines and a pool of other machines. And this is done by project IDs. So you may say project ID Z is the owner, project ID A is the lessee, and they can see an overlap of machines. Or they can be completely different, and they may see none of the machines. But when accessing it via the project ID, you only see what you have rights to see. And we'll get into that. But system scope. How many people here have heard of system scope? Awesome. So long story short, the original idea for system scope was to think of the system as itself. And the idea was that an operator would have the visibility and ability to manage the entire system through this role without context of a single project. For Ironic, this makes lots of sense because Ironic was an admin-only project previously. There were no other users or consumers of the API. So in this model, you have an admin, you have a member, and you have a reader. An admin can create and delete resources. A member can change and modify resources. A reader can view resources, and that's generally excluding items which are restricted by security, and we'll get to that. But then you also have a service role in newer releases of Ironic. And the whole idea with a service role is a specific role for another service to do service-like interactions. So the example that we've used is Nova Compute connecting to Ironic to do service-specific things. It's not a requirement for use. You should be able to use another member role, should work just fine for most operations because you're not creating physical nodes. You're deploying them. There's a difference there. But then there's project scope, and everyone knows of project scope. It's the scope every user exists in, or at least every normal user and tenant and everything else. So in project scope, there's admin, member, manager. I said that out of order, but admin, manager, member, and then reader. And the access is very similar. An admin and manager are very, very similar in a project scope of use. A member still can just change and modify resources. A reader can still just view and read resources. So but when we start laying this up in the model, we have an entire system scope of access, and then in project scope, we have owners and lessees nested into that. So when you start thinking about that, it means an owner can see a lessee's machine if they've leased it out. A lessee can see nothing else. And someone in the system scope can see everything. And to kind of further explain how the access is modeled, a system scope member is very similar to an owner admin or manager. And a member for a project scope on owner is very similar to a project scope lessee member. And in reality, there really aren't that many admin things a lessee can do on the API, or a manager for that matter. It's restricted. And for example, and I have the actual policy rule here, which is kind of frightening. And it is, yes. It is frightening. But I want to kind of provide a somewhat graphical explanation of what it looks like. So effectively, if I want to change lessee, everyone that's grayed out cannot change lessee. Only those that are not grayed out can change it. So to update the lessee field, you have to be a member and in the system scope, or a role service, or a member with a project ID, which means an owner can change the lessee. Note there is no lessee in any of this. Same basic logic applies, but for owner. Only system scope can change owner. And this logic also gets applied very similarly with queries on fields. An example of the chassis field type is there is no project logic applied. It's restricted entirely to the system scope. And if you want to change provision state, well, I see a lessee there, and a manager, and a lessee, and an admin. Well, they can redeploy their own machines. Cool. And the reason for this is because operators were deploying machines and then asking and filing tickets to have machines rebuilt manually. So they could still power it on and off with Nova. It seemed logical, at least logical to support it. And that's what we're about, is making it easier for operators. Yet another example. We have a concept of node history. What has happened with this machine? And in this case, you can see the owner can see aspects about the machine. And those in system scope can see what's going on. Lessee can't see what's going on in that field. They don't have the rights. Actually, hold on. And I have screwed this slide up. So anyway, so a question that's probably in people's minds is, if I have a node shared by a system and an owner and a lessee, how does that work? Well, if you're asking for a list of nodes, we get a request, and Oslo middleware fills in the missing details. It tells us what the roles are, what the scope is, and what the project ID of the requester is. And then we apply an access rule. If this matches, then we take additional action. So in this case, we have a, can they just see everything? And this is a intentional shortcut in our API logic, because it takes a lot of overhead to apply access rules for every single node. So we went along the path of going, do we make it easy, simple? And so if a user matches this rule, yes, they can see everything. There's no restriction. And we just return the list of nodes. But if they don't match that rule, then we apply the project ID and match the owner and lessee fields. So if you have a project ID that says, that's set to ZZ1, and that matches the request, we'll return the nodes that only have the project ID of ZZ1. Very similar to ports, there's an additional step in the logic, which is if there's a subcontroller. But basically, we get the request, we fill in the details, we do a validation if it was from a subcontroller or not. We then apply this list all bypass. If it doesn't match, then we request a list of ports joined with the nodes based upon if there is a owner or less a field populated. The end result is, if there isn't, there's no node list. You get an empty result set. And the list really goes on to kind of provide scope of to how many rules there are. There's 101 deprecated policies at present in Ironic, 97 non-deprecated policies, and every major API feature or field that requires access controls gets yet another policy at times. Because, or actually, I should have had this in a different order. Anyway, we'll get to that in a moment. But you can see here is an example of the deprecated policy with a nice warning, and then the actual newer policy. And this is the generated output if you were to customize it. But this is where I wanted to go to, is depending on the policies, some fields are restricted by the API, and this is to protect us from exposing administrative details or secrets. Information that could be used by an attacker to gain more insight into your infrastructure. So the idea is, if you don't have enough rights to see the field, then we just replace the contents in the payload, because they don't have rights to access the field. And we put a warning in. We try and make it friendly instead of return an empty dictionary, which no one wanted, except me. So, but then we did some additional work, and we have now this concept of implied lessons and owners. So now we will attempt to extract the project ID on the original requester when you ask to provision a machine. And we'll add it, if so configured. So you can deploy a machine from Nova, where we'll ask Ironic to deploy it. And then you can go log in, access Ironic with the same credentials that you asked Nova to use, or that you used to access Nova to perform the deployment, and go, oh, I want to change the power state now, directly. When we tear down the machine, we remove the access, world goes on. And commonly, this is because people were asking for machines to be rebuilt in physical environments. And now, in Z, we also added the ability for project scoped admins to create their own nodes and have the owner field automatically set based upon their project ID. Simple, small little things to make operators' life easy. It's what Ironic is really about. In summary, there's a lot here. I hope that I have given you a high-level overview and that you're now aware that, wow, there's quite a access model there that is extensive, and it is available for use. And ultimately, we're here to enable the needful with cascading access and explicit access where needed. Any questions? No questions? None? Thank you.